ladies and gentlemen, I'd like to now introduce Mr. Safal Somvanshi. Mr. Safal is results-driven sales and management expert with over 20 years of experience. Currently, he is the vertical head of packaging at Cognex India. He excels in driving sales and managing operations, specializing in business analysis, market trend monitoring, and strategic implementation. Safal is adept at expanding business accounts, managing budgets, and leading projects with a focus on client satisfaction. With a strong track record of recruiting, training, and achieving significant annual sales revenue exceeding 7M USD across India, Sri Lanka, and Bangladesh, he ensures effective resolution of client queries and grievances, contributing to overall business success. Today, Mr. Safal will talk on digitalization of packaging inspection. So without further delay, let's welcome Mr. Safal.
Okay, so let me start with my presentation. What we are going to see today is the brief Cognex introduction and machine vision introduction, then trends, Industry 4.0 and digitalization, and how AI is taking over rapidly to the rule-based traditional camera vision system. And we will talk about few industry application on the packaging market. So what is machine vision basically? So vision is something which for a human body, what we see through eyes is what we see through optics. That's exactly what a camera does for doing the inspection. And then it has a software and algorithms and which are on the camera side, and what we see is what we process in the brain, and then that's where we get some results. Okay, this is good, this is bad, or things like that. Now, what is the evaluation of machine vision? Basically, if we look at Cognex, we are doing only machine vision and nothing else. If we start at 1982, that's the size of the Dataman barcode reader, which is a very small size for now, hardly something like this. So that is the technology advancement in last 40 years of the time. Now, obviously, Cognex, we are a leader in the industry of machine vision, and here are some basic facts about our organization. So we have been in this business over 40 years, and we have over 25,000 satisfied customers. We generated over little more than 1 billion revenue, US dollar revenue last year. We have 60 plus offices in 20 plus countries, 500 plus channel partners, because vision is not always the complete solution. So it's a part of the solution. So we have a strategic partners who will provide the complete solution with software integration and vision and rejection mechanism, PLC integration, and stuff like that. And we have more than 35 million systems installed at different various applications. Now, one special thing about Cognex is we spend every year more than 16% of our revenue in R&D, and this gives us 1,000 plus patents for now, where these are some of the key features of Cognex products. So for example, there are a few algorithms which are patented for years now, and nobody else can provide those algorithms in their machine vision systems. Now, Cognite, so that's what we call us, the employees of Cognex. So Cognites, as we call ourselves, we bring a wealth of vision application. So after 40 years of in this business, we have tens and thousands of similar applications which we have seen anywhere else and across the globe. So we have that kind of expertise in terms of having the experience of solving the applications which we have already done somewhere else. We have worldwide sales and training support. And we are doing more than 9 to 10 languages, the global training and education, depending on the country for our customers. Now, why Cognex? So basically, we have 3 different tools where we have a powerful vision tool sets. So there are something patented algorithms which we call as PetMax, PetMax Redline, OCR Max. And so these are some patented algorithms which make our equipments very, very strong in terms of processing, in terms of giving result faster than any other vision system in this world. Second point is we have unmatched flexibility. So basically what happens is if you are buying some vision system today for application A, and tomorrow, 2 years down the line, that application is no more important for you, or you drop that application. So what we do is we use the same hardware, with different lenses and filters and polarizers and accessories. And then the same hardware can be used for another application, which is a flexibility in terms of, and these are all field changeable equipments for the filters and polarizers and lenses and lights. Third is obviously deployment. So we have various platforms which are actually a plug and play devices with all kind of robotic systems, which are plug and play with all kind of PLCs. So there is no handshaking software required in between. Integrate it with other devices. So for if I have to give an example, if we talk about any robo, Cognex, all smart camera systems are just plug and play for them to exchange the data to the robot, to give the coordinates, to do the pick and place and stuff like that. Now, if we look at portfolio of Cognex, primarily we have products in two categories. One is ID, that is mostly application related to barcode scanner traceability, and second is vision. So depending on different applications, on what tool sets you need, what are the speeds, what are the size of the barcodes, what is the working distance. So there are different products which are available, and Cognex can offer you the most optimized solution on barcode traceability. Similarly, on the other side, when we talk about the vision application, where we are doing some measurement, some sorting, some pick and place. So these are kind of applications. So the ranges which we talk about, Snap and IS2000, these are the very basic application sensor replacement products. Gen 2 is something which is we have been using years together now. These are the rule-based cameras. Third one is the new range, which has recently been into the market for last 4 years, 5 years. In India, especially across the globe, it came not before. So there is something which is deep learning and there is something which is edge learning. So we will see what those things are. And then there are 3D systems which are used for pick and place, very precise measurements and stuff like that. Now, in all these applications, how Cognex can help you is this will reduce whatever you have on left hand side, and then this will improve your quality product and stuff like that. So if I have to go through this applications or go through the points which will take care of the product recalls, which eventually is impacting on this 7 8 factors for us or for customers, we will take care of that. So typically when you say what are the applications on inspection points, these are the four things which we are all which are always all the applications are categorized into these four things. So one is guide, second is inspect, third is gauge, and four is identify. Now any application in machine vision will fall only under these four factors. So guide is something where you give a precise coordinates to robo pick and place. Identify is something where you are reading the codes, you are doing the barcode reading or dot code reading on the products. Third is where you are doing the gauging, that is XYZ kind of measurement. And fourth is inspect. So where we are doing the inspection. Now, when we talk about machine vision in the past, it was always considered as a hurdle in terms of machine vision. So vision was earlier always considered as an obstacle or loss in productivity because so the systems were normally bypassed. Now with Industry 4.0 and other stuff, what is happening is you always need the data to be monitored or accumulated at one point, at one level, and then you do the complete analysis of this data in terms of looking at the overall OE of the organization or a shop floor, and then improving the performance on the equipments. So with this now, it's considered as a very important tool to have the data dumped at a specific location. And then what Cognex can do is Cognex can connect all their vision systems and cameras and give the data to your SAP system, where we do the monitoring of all the equipments and all the data and do the process improvement on the backend. Now we have some barcode scanners. So barcode scanners are typically used for traceability in the system. And if you are using hundreds of barcode scanners in one shop floor, typically you can collect all that data through one device, which is called as edge intelligence. And this will give you a facility to dump that data into your cloud portfolio as well. So that's the kind of data integration or data dumping can happen with a Cognex vision equipment. So we all know today that having the data management is very, very important, but then getting the actual data from the ground floor or shop floor, that's where Cognex comes into picture and really helps in providing this data. Now, this was all about the basic barcode side scanners. Now, there is something which is deep learning or artificial intelligence, which we all talk about currently. So, Cognex is the first company to introduce a smart camera deep learning solution, which is not a PC-based one, and everything happens inside this camera. Now, today we see that lots and lots of, there are factories, there are millions of human beings doing the same monotonous job at one specific place, sitting for all 8 hours, and human beings tend to make mistakes when it comes to the repeated or monotonous jobs. So that's where AI comes into picture, and AI helps us in resolving this solution. Now, why deep learning or AI is different from a traditional rule-based cameras? So basically, as we have heard before, so there could be 10 different or 20 different kind of houses. So every time when a child goes, we explain the child that, okay, this is the house, this is second type of house, this is third type of house. But then there are, so when you teach the child about 10 different things, then the child knows that, okay, this is the house and this is how the house will look. Then at 11th place, child might get confused when you take the child to the office, and that's where you do the correction that this is not the house, this is the office. And that's how you build the neural network and it starts working. Now, where do we use deep learning? Earlier, there were some applications which we were not at all able to do, like scratch identification, dent identification, cosmetic inspections, and stuff like that. So that is one thing. Second is where we were taking more time with the rule-based camera vision systems, or we are not getting the good repeatability in terms of performance. So we have a false rejects more with the standard rule-based systems. Their deep learning can work better. Now, how does deep learning work basically? So what we do is we collect a lot of images, we sit with a quality person, we define or label it, good or bad parts, and then we teach the neural network of the camera, and then camera starts performing. But remember one difference in a standard rule-based vision system and artificial intelligence-based vision system. Here we are building the neural network of the camera with good and bad parts, along with a quality person or the production guy from customers end to arrive a golden configuration. So imagine a situation where we train 100 products. Customer says that these 90 are good for me, these 10 are bad. And then we teach the neural network of the system. Camera starts running accordingly. And then customer might feel that, okay, out of this 10, I can still reduce 5 to the good part. So we again do that teaching. So now we have 95 good parts and just 5 bad parts. In this entire process of teaching, we might come across the situation where we have 2 or 3 defects which we have never seen in this 100 samples. So that's how this neural network is developed. And then we start doing the total inspection in terms of identifying a golden configuration and start giving results. Now here is a short video of how a system.
The pressure on the food and beverage industry to optimize efficiency without compromising on quality is challenging. That's why successful manufacturers use machine vision systems, such as the Insight 3D L4000 from Cognex, to minimize downtime, avoid recalls, and consistently deliver safe, high-quality products. For example, an Insight 3D L4000 uses PatMax 3D to locate the can, and uses a combination of plane and blob tools to see if the tab is lifted or if the can is dented. Volumetric measurement ensures these cereal bars are properly portioned and are free from any defects. Gauging tools then confirm each bar is sized to the correct dimensions. A trickier application, like these stacked cookies, is easily solved with PatMax 3D and blob tools, making sure the correct number of cookies are in each package. All of these inspections are easily set up and deployed within the Insight Vision Suite. Advanced optics and a patented speckle-free laser ensure unmatched image quality. And it's all bundled inside an IP65 rated housing as a standalone device. To learn more about the Insight 3D L4000, visit cognex.com and schedule a demonstration today.
So Cognex has introduced the world's first 3D product, which is based on the AI toolsets. So it will have a standard rule-based toolsets as well as the AI toolsets. Now, these are few of the examples where we are already doing a lot of applications across the industry. So if we talk about pharma, we are doing QR 300 regulation, barcode verification. Then we have done traceability since 2017, where we are building aggregation, child-parent relationship in terms of traceability and dumping the data into government portal, which is the demand for pharma industry. This is another example where we are doing the bundle scanning in the shipper carton. Few of the other applications are a 2D code reading on the part, which is again on the ID side of the application. On the edge learning tools, so edge learning and deep learning. So deep learning is for very complex applications like cosmetic defects, where we teach lots and lots of image. So edge learning is something which is a subset of AI, where we are teaching just 10 good images and 10 bad images, and that's it. The system starts performing on its own. So these are few of the application where we are doing the joint inspection, we are doing the tablet bad part inspection, we are doing the assembly, presence absence of the components and stuff like that. This is something where we are doing the classification with edge learning tools, as I mentioned. So there are very few differences in terms of these gears, and you have to do the classification where they are running on the conveyor and they should go to the specific diverted conveyor. Once we are doing the classification, those kind of applications, we are also reading the characters where the backgrounds are not very clear and stuff like that. Now, these are some of the applications which we are running at various places. So this is the print quality on the top. And this Cognex 3800 vision system is running at 1550 products per minute, doing the OCR and character reading. Now, if we look at the print quality here, it is even bad. And here, this line is working at around 400 speed, 400, 450 products per minute, where we are doing again the character reading. And the third one is on the chocolate wrappers, which is running at 700 products per minute, roughly. Now, again, why do we barcode verification? So this is one of the important topics for pharma industry, where we are talking about why do we need verification. So to ensure the repeatability, avoid recalls, because reduce scrap obviously and increase OE. So what happens is, typically when we talk about verification, there are barcode verifiers and there are offline and inline verifiers. So in terms of earlier, what we used to do when there were no online verifiers available, we used to pick up some random samples from the line. We used to do the verification on the lab, and then we used to paste that report along with that batch, which is getting exported. But now, if we talk about inline verification, we can scan or do the grading as per ISO standard for each and every code that you are running on the line. And you get a complete report in terms of 19 parameters, which is as per ISO standards, which is required for gradation of a solution. You can have different types of output formats and stuff like that. A few other examples where we are using deep learning is identifying the spoon check at a very high speed, doing the contamination inspection inside the bottles. Now there is new regulation which is coming up, where we are supposed to read the characters on the blister and read the 2D code, because typically there are 10 blisters in the pack, and then we don't sell the entire pack. So that's where government wants this traceability now. Another application which we have sold a lot during COVID times is the vials and vaccines counting. Similar application is there for cigarette filters, where the filters are not manufactured in the same shop floor, and those are coming from outside vendors. Those are coming in a big container where 6,000 or 4,000 filters are there. And then we are scanning and counting it at one point of time. And if there is a variation of more than 1% or 0.5%, depending on the criteria, we are accepting or rejecting the same. Similar foreign material or cosmetic inspection, where on the left hand side you can see all the good parts, on the right hand side you can see the camera images. So wherever there is foreign material, where there is a gap, where there is an air bubble, we are identifying those kind of defects. Surgical kit verification or assembly verification rather. So there are maybe 10 parts in one kit, and then we have that in a specific orientation. So we do all check that. Then voids and ampules inspection, where we are doing different kind of inspections, dimension measurement, field level check, and stuff like that. This is one example where we are doing OCR on carton at a very high speed, inconsistent print quality, and high speed. This is again the OCR on inkjet technology and on a flexible laminate. This is on the crimp area, where we are looking at these characters for traceability, and even there is a black eye mark in between. Even then, the deep learning is reading this kind of characters very clearly at very high speed. This runs at 750 products per minute. These are few applications of OCR where we are reading very difficult characters through deep learning technology. And now here are some examples where we are looking at a 3D inspection. So we are doing the bar counting within the multi-pack or the outer carton, which goes in. Here we are doing inclusions identification. So in a specific area, there are supposed to be a specific nuts. So we are doing that kind of inspection. Then we have already seen this biscuit breakage inspection or continuity inspection, which gives you the 3D dimension and stuff like that. And here is again the prepared meal inspection, where we are checking at whether all the parts are present, whether they are present till the right quantity, and whether they are in a right orientation. So this is how we are looking at it. So this is how it gives you the 3D view of what is placed where, whether it is placed in the right density. So it combines a 2D and 3D image and gives you the actual result of what is present, whether it is present in right orientation and stuff like that. And then here are some defects which we are identifying in cookies or noodles or biscuits, where it is continuous, where it is broken, whether it is not in a right size, stuff like that. So again, just to conclude the last slide, why Cognex? Because we have powerful algorithms, which is like PowerGrid and HDR Plus, where image processing or image capturing becomes much more clear. Unmatched flexibility due to field changeable or parts, lens, lights, and accessories and stuff like that. And ease of use, because the Cognex have a standard platform softwares, which makes it very easy for communicating with other devices like robots and things like that. So that was all from our side, which we wanted to present today.
Thank you, Mr. Somvanshi, for talking about digitalization of packaging.